So we'll start with the SV system Verilog. Okay, system Verilog so we already completed with the Verilog. No, so do you have any idea about the difference between the Verilog and system Verilog? Yeah, system Verilog. System Verilog. We are mainly nowadays some companies they are using system Verilog for the design also, but most of the 90% the system Verilog we are using for the verification. Okay, so we wrote the test bench now. So we wrote the test bench in the Verilog to verify that correctness of the circuit, but by using system Verilog we can verify the circuit. So, compared to Verilog, how it will be different means why we are using this SP. Okay, why we are using this SP means first is I will write here. One is randomization. Okay, randomization. That too with constraint randomization with the constraints with constraints. Constraints means with some conditions. Constraints are nothing but with conditions we are writing the randomization. Okay, randomization with constraints. Okay, so randomization with constraints means suppose if you take suppose any RAM design is there. Okay, so this RAM, let us take I'm designing 1 KB cross 1 KB RAM. Okay, so it have clock and next reset, write enable, and next read enable, and data in. Okay, and write address, and next we have read address, and next output is data out. Okay, suppose in the test bench, suppose in Verilog, so in the test bench if I want to generate the stimulus, okay, that means here I want to generate for write address. Okay, write address is how many bits means suppose if you want to design 8 cross 8 RAM, write address is a 3 bit only. Okay, so you will use a system task that is what dollar random. Dollar random. Okay, so dollar random is what? Dollar random means it will generate the random values. Okay, it will generate the random values only. Okay, but suppose if I want the values, that means randomly it will generate. Okay, we can't predict that value. Okay, suppose I want to generate the values from 0 to 50 or 100 to 200 with some conditions. Okay, these are what constraints. Okay, constraint. Okay, so randomization means what? We are generating the stimulus randomly with constraint, with some conditions. Okay, so that we call as what? Constrained randomization. Constrained randomization. That constrained randomization is there in the system Verilog. That is not there in the Verilog. Okay, is it fine? This is the first with respect to difference between the Verilog and system Verilog. Is it fine? Shall I move forward? Okay. Next, if you take a test bench, if you take test bench, there are two. That in Verilog, this is a linear test bench. Linear test bench. In Verilog, we are using linear test bench. So linear test bench means what? So we are giving a fixed values, fixed constants. We are driving some fixed values to the stimulus. Okay. In the system Verilog, we are using layered test bench. Layered test bench, that is we are using in SP. Okay, so what is this layered test bench and all those things? Mainly we are doing the verification means we are developing the test bench only. Okay, in SV we are developing the test bench. Okay, so that what is layered test bench and all those things we will discuss in the coming classes. And next you have functional coverage. Okay, functional coverage. Functional coverage means what? What is coverage? You know what is coverage? Yeah, yeah. So that means here in the SV you have functional coverage means suppose if you have DUT. Okay, we have DUT. Some inputs are there. Some inputs you are driving. Okay, to this DUT. Okay, so that means this DUT cannot process some inputs. Okay, DUT cannot process some inputs. Okay, so that means in that position that the functional coverage is not 100%. Okay, but in SV we need to see the functional coverage such a way that we need to get 100% functional coverage. One more is we will study about code coverage also. Okay, code coverage also. So we will develop a project that is a dual port RAM. So dual port RAM will develop the test bench. Okay, dual port RAM will develop the test bench, and we are going to generate the code coverage as well as functional coverage. Okay, in our SP. Okay, best example is your FSM also. FSM. Okay, FSM if you take, suppose you have like idle state. Okay, and next this is S1 by 1 state and S3 here S2 by 0, S2 by 0, and you have S4 by 1, and here S5 by 0, like this. These states are there. Okay, so here what happens means uh, suppose it is covering all the states. This is S3 by 1 and this is S5 by 1. Okay, suppose when it is going from S4 to S2, it is not checking. Okay, this one is not checking. So if it is not checking means what? So my functional coverage is not meeting 100%. Why? Because that input is missing. Okay, it's not checking that input in the FSM. Okay, so that we are going to verify all the possible combinations. Okay, which we are going to design. That is what functional cover. Functionally, it should cover 100%. Then only my design will verify 100%. And also it should satisfy the code coverage also. Okay, we need to check each and every aspect, every corner cases we need to check. That is functional coverage. Is it fine? And fourth is configurable. Configurable. So what is this configurable? So that means we are setting up something or arranging. Okay, so mostly we are using this configurable. Mostly we are using OOPS concept in the SV. We need to do some configurations. Okay, we can reconfigure some multiple number of times. Okay, so we need to reconfigure this one with multiple number of times, and we need to call so many times. Mainly we are using OOPS in the configurable. Okay, and next one is reusability. Okay, reusability. So what is meant by reusability? Reusability means what? We can reuse the design. Suppose like if you take AHB bus. Okay, if you take AHB bus, advanced high performance bus. Okay, AHB bus. Suppose this supports some burst mode. Okay, this supports some burst mode. Okay, suppose if you want to so this is my TB and in Verilog. When you are writing, suppose if you want to modify this AHB bus to APB bus, we need to change so many major modifications we need to make. Okay, so that means this will support burst mode and APB will not support burst mode. Okay, so burst mode we need to make in the test bench major modifications, like we need to change the instantiations and all those things we need to change. Okay, so but by using SV, okay, with some small slight modifications we can use, we can make modifications. Okay, slight modifications we can use this AHB text bench for APB. Okay, that is what reusable. We can reuse our design in the text bench that is there in the SP. Whether in Verilog we need to do more modification, but in the system Verilog we need to do some slight modification. We can reuse the design. Is it fine? That is reusability. Do you understood? Shall I move forward? Okay. And next is assertions. Assertion. Okay. Assertion. So do you heard this assert de-assert when I'm talking about reset, we need to assert the reset, we need to de-assert the reset. So that means we are applying the assertion. Actually, like in the Verilog, we discussed about the TB. Okay, Verilog TB test bench. So how we are giving like this is my DUT. You are driving the values to the test bench. Okay, so you are driving the values to the test bench. So that this is what actually like this is actually black box. This is actually black box. So that means here you only designed and you only wrote the test bed. But suppose if I give my design, suppose if I give my DUT design and test, I will tell you to verify this design. That means I will tell you to like I don't tell the functionality and what is the functionality and what is there in that code, and I will not tell, just I will give it to you and I will tell you to write the test bench. Okay, so then you can't find out that is what is there in the design, no. So actually that is what black box. Okay, so when you are verifying and simulating, after 100 simulation time, you came to know that you will get one bug. Okay, next what you need to do, you need to go to the design and you need to change your design. Okay, so this type of verification we call as what Verilog TB. So Verilog TB is a functional verification. Whatever the text bench you wrote for the Verilog, that is what. So we don't know. So actually, when I give the DUT, so we don't know what is inside in this. Okay, this is what block level verification, like closed loop. Okay, so we call it this block level verification. Okay, we don't know what is there inside. But coming to the SV system Verilog test bench, we are using assertions. Assertions is very separate topic. Okay, this is what actually this is block box visibility. You don't know what is there in the design, but in assertions there is a white box visibility. White box visibility. So what is this white box visibility? That means we can find out the bug during the verification itself. We can find out the bug during the we know where is the bug is located. Okay, where is the bug is located? That is nothing but white box visibility. So SVTB, so mainly we are using assertions. So that is what formal verification. So many job opportunities are there in the formal verification. They want this FV engineers. So FV engineers means you need to be perfect in the assertions. Okay, assertions is a separate topic. It will take I think 1 week of time for completing these assertions. After completing this code coverage, functional coverage, after completing the dual port RAM project, I will start with assertions. Okay, so that means actually like so SV and UVM actually like those are easy languages only. Okay, so compared to Verilog, SV and UVM is easy only. But so normally like so you need to follow me and you need to follow my lectures. Then so I given like a structured way. So like references. Don't open this. Just after completing the course, you open this. So reference you go to this LRM language reference module. Language reference module. Okay. So in the DB core drive, I shared this also. So now it's don't open this. Just to follow this whatever the materials and notes. And UVM also it's easy only. UVM is not a language. It's a methodology. It's a methodology. Mainly we are using SV under UVM. Okay, SV under UVM. Actually, mostly the heart of SV is hoops only. So what is the difference between this? Actually, like what is the difference between SV and UVM is so SV. Suppose let us take you have SPI module. SPI module you are writing the test bench. Next, if you want to write the test bench for I2C, so there is no proper guidelines are there. You need to come from the scratch. Okay, this is robust. There is no guidelines further. But with slight modifications, we can use. So already like in UVM, already predefined classes, base classes or parent classes are there in the UVM factory. Directly, you need to just inherit those classes and those classes, and you need to write. And there is a UVM factory. You need to register. So most of the all companies they are using UVM for the test bench only. So there is a company they called Accelera company. They made this UVM. Okay. So if you are good at SV, then UVM is easy only. Okay. Is it fine? So randomization, test bench. Okay. So randomization means what? Constraint randomization. Test bench, linear test bench, layered test bench. Functional coverage, code coverage, configurable, reusable, and assertions. Okay. So again, assertions. In this assertions, you have when you are writing the Verilog, that is functional verification. When you are writing the assertion, that is formal verification. And about the SV and UVM, difference between SV and UVM. Is it fine? The introduction to this CSV. So we are going to discuss about these concepts separately, but I given a brief idea about what is SV and how it is differ from the Verilog. Shall I move forward? Okay. So next coming to the next part, that is we'll start with the data types. Data types. Okay. So data types. We in the Verilog we studied about the four-state data type. What is four-state data type? Did you remember? Verilog, yeah. Yeah. We studied about wire data type, reg data, integer data type, real data type, float data type. We studied about that. Okay. So that means those are what, one second. Those are we call as four-state data type. That means the value can be what we already studied about the value set now, 0 to Z. Okay. And, and in SV, some data types are what? Two-state data type. Two-state data type means what? Those values are either 0 or 1. 0 or 1. So in two-state data type in SV, you have some more data types are there. Those are bit, byte, and int, and shortint, longint. These are the two-state data type. Is it fine? Okay. So in SV, one more four-state data type is there. That is one more four-state data type. That four-state data type is logic data type. Logic data type. Okay. So logic data type. So logic data type where you are using means when you are writing the code, did you got any confusion like suppose when you are using continuous assignment statement or procedural assignment statement, where I need to use the wide data type, where I need to use range data type. You got any confusion when you are writing the code? Yeah, you got the confusion, no? So that confusion can be overcome in the SV with by using logic data type. This is similar to reg only, similar to reg only. So logic data type. So logic data type, the default value is x, and width of this is 1 bit. Width of this is 1 bit, and this is unsigned data type. Unsigned data type. Okay, so that means here what is logic data type? So we can use this logic data type in procedural assignment. Okay, procedural assignment, that means we can use in the initial or always block, or we can use in the continuous assignment. Okay, so in the data flow modeling we can use in the continuous assignment statement also we can use. Okay, it will take, okay, continuous assignment. Okay, this is about the logic data type. Okay, so we'll see one code related to this one second, logic data type. I'm opening this, one second. One bit. It's same as reg only. Suppose reg A is there. Reg A is how many bit? One bit. Same as reg. It's same as reg only. So you have one bit data type. Okay, one bit data type. So here I wrote the code. This is test bench. Yeah, this is logic data type. Okay. So if you see this logic data type, so module logic underscore data type, I am declaring logic A and logic B. So this assign A equal to 1. So where I'm using in the continuous assignment statement. And initial begin B equal to 0 and hash 5 B equal to A. Okay, I'm displaying, that means I'm assigning after 5 time minutes, I'm assigning B equal to A. I'm displaying this value, A equal to percentage B equal to percentage B, A comma B. So that means I'm using A in the continuous assignment, I'm using B in the procedural assignment. It will take, okay. So just select all, copy, and go to the EDA playground, and next, uh, so paste it. So in the EDA playground, I told you here we need to write the design, here we need to write the test bench, okay, and language variables are same only, and next go to the tools and simulators. You need to select Aldec Rivera, run this code. So what is the value you are getting? A equal to 1 and B equal. Is it right? Logic data type. Okay. Yeah. So next we'll go with bit data type. Okay. So what is this bit data type? So bit data type is how many state data type? I told you other than logic, remaining all are two state data type only. Okay. So yeah, two state data type. So bit data type. So bit data type, if you take, this is a two state data type. Two state data type. And what is the default value? Default value is 0. When you are giving don't care means it will take it will give us like 0 only. Okay, if you are giving don't care means it will give us 0 only. That's why default value is 0. So what is the size of the data type? Size of the data type is 1 bit. Okay, and this is unsigned data type. Unsigned data type. Okay, which one? Logic data type is unsigned data type. It's same as reg only. No, we in the Verilog we already seen, no, wire data type, reg data type are unsigned. So this logic data type is same as the reg only, but it will overcome the confusion that we can use this logic data type either in continuous assignment statement or procedural, anywhere we can use. That confusion, actually these are unsigned only. When you are giving negative value, it will execute in positive only. Okay, unsigned data type only. You can check here. Suppose here it is there, no. So here I am giving a equal to minus 1 is there. Okay, a equal to minus 1 and b equal to some minus 2.